Okay, in this tutorial, we are going to recreate the head block from blockr.core. As we can see in the application on the right, what the head block allows us to do is from some incoming data, select the number of rows we'd like to return. So here we can toggle this numeric input to control the number of rows returned. And also we have this head and tail switch to switch between the head and tail of the dataset. Now, for our tutorial, we're just going to focus on this numeric input and ignore this switch, just to simplify things as much as possible. And a note, this intro tutorial is aimed at our software developers, so it is expected that you have a good working knowledge of R packages and also of Shiny reactivity and Shiny modules. If you don't have those prerequisite skills and knowledge, then we recommend you follow the readings in the description of the video below. Okay, so in our editor, what we can see is the skeleton of an R package. And what we're going to focus on today is this head.r file, and this contains essentially the most simple module we can build. So we'll cover the kind of top line principles, and then we'll delete the code and then line by line recreate what we've done, diving into some of the more finer details. In terms of the other files in this package, our package file just controls some of the imports. So here we're assuming we have Shiny and blockr core imported because we'll be accessing some of the functions from those packages. The virtual classes we'll cover at the end. And then finally, this .onload call. What this does is it registers the blocks we create. So later we're going to see that we have an example app we're going to use to test the block. And the reason the example app knows how to find our head block that we're building is that we load them with this call to register example blocks. But we're not going to jump into details of how this registry works. For now, we're just going to focus on the anatomy of our head block. So in principle, every block in Shiny is just a fancy Shiny module. So if we look in our new example head block function, we'll see that we have a UI function and a server function. And we also use module server and namespaces, very much like you'd see in a standard Shiny module. The main differences are that our block should also return a list object containing an expression and a state. And these expression and state are required by blockr. And we're going to get into exactly what these do later. The other differences we might see is that our Shiny module is bound in this new block function call, which is bound inside of this constructor function. And the other unusual thing is the placement of this data here. And again, we're going to get into all these details as we build this up line by line. So let's start by just getting rid of our block code and then building this up one step at a time. So every block's going to start with a constructor function. And I'll quit, that's okay. So let's call our constructor new example head block, for instance. And this is just a standard R function. Now what we want this constructor to return is a block object. And the way we do that is we're going to call new block from blockr.core. So let's bring up the documentation. Maybe I need to load the package. And it looks like Positron isn't playing nicely for me, so let's restart. And let's go to blockr.core, new block. Okay, now we're back in action. Okay, so we can see that the new block function requires a server, a UI, and a class. For now, we're going to ignore these other arguments and just focus on these three. So I like to start all of my blocks by first creating the UI function. So this is just a standard Shiny module UI. The only difference, I think, is that we try and enforce that the UI here in your block returns a tag list. In this case, in our tag list, the first item we want is the numeric input. So if we looked in our old dead app now, we'd see that the first thing in our kind of block is this input. So that's what we're going to recreate. So get numeric input. The first argument is going to be input ID. And here we need to use namespacing because it is a Shiny module. And let's just call our ID n. And the next thing we need is a label. So here, let's say select number of rows. And then finally a value. Let's just call this value n. And then we might also want to specify we want a minimum of 1 row. Okay, that looks good. The next thing we want is we want to return the actual data. So we need to render that to screen as an output. So here, let's just use the DT package and say DT output. And now we need an output ID. But again, we're going to use namespacing because we are essentially in a Shiny module. So let's call this result. So that takes care of our UI. Now, if we go back to our help, we'll see the next thing that the new block function calls, which creates our block, is a server. So let's add the server call now. So server. Now function, because we're using namespaces, we need ID. And the next thing we'll do is pass in data from the block higher up in the graph. And we'll get into how this works more shortly. Now, like every Shiny module, we need to call module server, and here ID, and then we have the function input, output, and session. And then from here, we can now start writing our server code. So the first thing we need to do as a block author is capture the default value we want for our block. So again, going back to this app, we can set a default value here. And we can do this programmatically in the constructor function signature. So here, we might want to say that n equals, let's say 6. And we're also going to pass in ... Now, first thing to do is capture this default value of n. And the way we can do that is we can just create a new reactive variable to track this. So let's call this new reactive variable n rows. Let's just assign it as a reactive val and call it n. Great. So now we can capture this default value in the function signature. The next thing we might want to do is now capture what the user inputs in the UI of the block. So what we need to do next then is call an observe event. And in observe event, we're going to say track the input n. So here we've assigned our input as n. And then let's update our reactive value we just created n rows by the value of that input n. So now collectively we can track the default value in the function signature, and we can also track if the user overrides this by playing around with the input. Now we've done that, the next thing we might want to do is render the actual output to the screen. So to do that, we can just assign output, and we called it RID results, output $ result, DT, and now again, we'll use a DT function. This time I'm just gonna say render DT, and then we have an expression. And what I want expression to be is, well, we wanna call the head function from utils, and we're gonna say data, and then n equals n rows. So what's happened here? In the server function, we can put inputs from other blocks. Now these shouldn't be exposed in the constructor signature because these are dynamically provided in the server by blockr. So instead, we supplied them in the signature to the server. That means that anything in the module server can access these inputs. So here, because it's a reactive input, we call data as reactive. And then finally, we also pass in our reactive value we created and rows, and we pipe this into our expression, and voila. Hopefully what we'll find is that we can render our D table using the input data set and our reactive variable value, that we've created. Okay. Next thing then is we need to return a list object with an expression and a state. So let's just create a list, and then we have expression. Let's just put null for now, and then state, which is also a list. And again, let's just put null for now as a placeholder. Now, this is different to a Shiny model. These are extra things required by blockr. Now, what the expression is a quoted reactive expression. Basically, what we need here is some non-reactive R code that contains the computation for our block. And the reason we need this is in our applications, we have this show code button, and we can extract the logic of our workflows outside of a Shiny reactive context into kind of standard R code. Now, our expression allows us to capture that computation, so we have to manually specify it. And then the state, what this allows us to do is list all the reactive values that we've been tracking in the user selections. And this is useful because it means we can serialize and deserialize the app. In other words, we can kind of save and restore state. So this allows us to build functionality such as save and restore, which is incredibly useful for different users. So let's manually build both of these things. So for expression, there's many ways to do this. If you look at the different packages on GitHub, some use glue strings, others use metaprogramming like bquote from base R, and I think that's what we're going to go with today. So this should be a quoted reactive expression. So let's create a reactive, and let's use bquote. Again, we're not going to jump into details like bquote. It's expected you understand how this works, and if not, you're encouraged to look at the documentation. So in bquote, what we can do now is build our computation. So we say we want heads, head from utils, and then we're going to say pass in data, and then for our n, we're going to pass in n. So it's .n for the syntax, and then we have to specify where n comes from. So we're going to say n equals n rows, which is our reactive value we built previously. Okay, that looks good. So this should compute an expression, a non-reactive expression we can use outside of the reactive context. And then finally, for the state, we need to return a list object, and in here we can just say n equals n rows and just capture our n rows reactive value we created previously. I think the final thing we're missing from our constructor, if we go back to documentation, is we also need to provide a kind of block subclass. So let's also do that now. So we can say class, and here we can call this whatever we want. Let's just call it example head block. Okay, I'm going to hit save. Just double check everything looks good. Okay, so in inst folder here, we have this example app where we load our package. We call the blockr meta package, which gives us access to this run app function. And from there, we're going to create a first block, which is just a dataset block containing the penguins data, which is my favorite dataset out of the dataset package. And then we're going to call our new example head block. So here we have a new example head block. And we're just going to link these two blocks together. So let's restart our session and load the library. Okay, so it looks like I've made a mistake somewhere. Where is the mistake? Head, line 12, 17. So let's go back. Okay. So it looks like it's a mistake. Maybe I can look at the diff because we've deleted the code, and maybe we can identify the mistake that way. Aha, NS is, well, that isn't going to work. Okay, ID. Okay, let's go back to our example app. Nope, still an issue. So that wasn't even the one we found. Head, line 10. Again, I'm going to look at the diff. Hopefully just make it easier to spot the mistake. Again, another typo. The danger of doing live demos. Okay. Hopefully that is the issue sorted. Woohoo, great. Okay, so we've spun up our new block. Let's drag this over. And we can see the default of 6. So if we go back, so remember we specified a default in the function signature that has been respected. And then hopefully we can toggle our limits. Great, looks like everything is working. So this is about as simple as a block can get. The only way we might simplify this even further is to use some virtual classes. So in our constructor function, we call the new block function directly. But what we might like to do instead is create some virtual classes where we call the new block, and then using S3 dispatch, we can specify some methods for this virtual class. And what that will allow us to do is just reduce some of the repeated code and some of the rendering in our block. So doing so, we could now get rid of this, and we could also get rid of the render method here. And the reason being, if we put these side by side, is we've now just replicated this functionality, but as methods for our S3 object. And now that way we have an even simpler block. The only thing we'd have to do is put new example block here instead of new block. And voila, we've simplified this even further. But for now, we're just going to leave it without these virtual classes, as they add another layer of abstraction that people may not be familiar with. For more information on the kind of anatomy of a block and how to build even more complex examples, please look in the description of the video where we're going to link to vignettes in the blockr core, package documentation where we cover even more in-depth topics, and we run through this example in even more depth. If you have any questions, you can leave a comment in the video or file issues on GitHub or in the discussions on GitHub. Thanks for listening.